Hi, this is Mrs. Ballard. Today's lesson is about right triangle trigonometry, and it's going to be broken up into 5 different shorter videos. So make sure you work through all 5 of them on the playlist. Um, we're going to start. I am going to turn my camera off because I have to flip my computer to write on it. So then you aren't looking at my ceiling or at my nose. So I'm going to turn that off. You're still going to hear my voice, okay? So you do need to write down the essential question. How do I use right triangle trigonometry to solve problems? That's what we're going to be solving today. And by the end of the lesson, you're going to be able to do these 3 I can statements, okay? So I can use sine, cosine, and tangent to find the side of a triangle. I can solve an angle of elevation or angle of depression problem. I can solve for the side of a triangle using a 30, 60, 90, and a 45, 45, 90 right triangle. And do the best you can to squish them in there. If you need to, you can put some out in the left-hand column. All right, so the first part of this, I'm going to go ahead and use an old PowerPoint to just explain these because the animations were good. So on this triangle right here, we have a theta, and that's what that angle is. It's a Greek letter, and that is called what we call the reference angle. Trig ratios are used in right triangles. And the 2 angles other than right angles are called reference angles. So technically this is a reference angle and so is this one. We typically have 1 in a triangle that we work with for the most part, and that's usually whatever one is labeled, okay? And at any time if you miss something and I go too fast, you can always pause it and rewind. All right, so the hypotenuse, notice it's across from the right angle. The opposite is across from the reference angle, and the adjacent is next to the reference angle. So you're going to need to know that. And if you didn't catch the animation, rewind it, okay? So the sign, notice on the notebook page, okay? I'm going to go to the notebook page. There's a dashed line right here. So I want you to be writing these first ones above the dashed line, okay? So write these first ratios right above the dashed line. So the sign is the opposite over the hypotenuse. So the opposite angle over the hypotenuse, okay? The cosine in regards to the reference angle is the adjacent leg over the hypotenuse. And the tangent in regards to the reference angle is the opposite leg over the adjacent leg. All right, so the dashed line, now you're going to write below it. So this one should go right underneath the sign below the dashed line. So the cosecant of theta is the hypotenuse over the opposite. Notice that's just the reciprocal of sine. And CSC stands for cosecant. So this cosecant is the reciprocal of sine. The secant is the hypotenuse over the adjacent. And you'll notice that this is the reciprocal of cosine. And then the cotangent is the adjacent over the opposite, or the reciprocal of tangent. So we're going to flip back over here into our lesson, and we're going to talk about this in regards to the triangles that we are given. Now, some of you were with me in the spring, and we did very much this similar lesson. I did take some stuff out, so it's not quite as long, but we didn't have everybody there, so we needed to catch everybody up. So just bear with us and we'll get through this little bit of review because so you're really good at trig or good enough at trig to get through calculus. So the sign is the, so this is my, so what I like to do is here's my reference angle. I will go ahead and label it. I know this is the hypotenuse. I know this is across, so that's opposite. And I know that this is adjacent. So my sign is my opposite 4 over my adjacent 3. That means my cosecant is the reciprocal of this. My cosecant has to be 3 over 4. My cosine is the adjacent over the hypotenuse, so 3 over 5, and my secant would just be the reciprocal. My tangent is the opposite 4 over the adjacent 3. So my cotangent would just be the reciprocal 3/4. So looking at example 2 here. So my sine is the opposite 12 over the adjacent, the opposite 12 over the hypotenuse 13. Cosecant would be the reciprocal. My cosine, since this is the reference angle and I didn't label, did I opposite, adjacent, hypotenuse. My adjacent 5 over my hypotenuse 13. Secant is my reciprocal, so 13 over 5. Tangent is my opposite 12 over my adjacent 5. And we're not worried about reducing into mixed numbers or anything, just leave it the ratio the way it is. The cotangent would be the reciprocal 5 over 12.